Hello everyone, myself Pushpendra. Today I am presenting the assignment 2 of solid state CML 661. In this assignment, we will discuss about the structure refinement from the single crystal XRD data. So in this assignment, our professor share the data of the single crystal of the three different compounds, and from these data we have derive or we have draw the structures of the compounds, and we take the unit cell. We have also draw the unit cell of these compounds. So for this we have used these are the compounds that we have solved by this by the software olex2, and this is the unit cell corresponding to this structure, and this is the another compound that we have solved, and it is the unit cell corresponding to this, and this is the data or pxrd data. So we learned in this video how we have got these information from this by solving the single crystal xrd data. So this is the third compound, this is the ropa, and we solve this structure by using the olex software, and we got the unit cell corresponding to this structure, and also we got the pxrd data, powder X-ray diffraction data, from this structure after solving the data of the compound. So in this assignment, now we will learn how we do these things, all these things by the data given by the professor. So let's move on the OLX software. First, we will see that what is given by the professor. Let's open the data given by the professor. So this is the data. This is the data given by the professor. Data 1, data 2, and data 3. These are the three different compounds. Data 1 for the HCT, that is the hydrochlorothiazide, and second one is the RAML drug, and third one is the ROPA. This is the ROPA drug, and this. So basically, in the single crystal XRD data, there are the two types of the files in all the compounds, in all three different compounds. First one is the ins file. Ins file bole to instruction file, and second one is the HKL file. So let's open the ins file. What is given in this file? So by using the notepad, we open this instruction file, and we see that what is given in this file. So it is opening. So as we can see here, this is the title of the compound, and this is the cell parameter. These are the cell parameter. These first, second, and third, these that I have marked, these are the latest parameters, A, B, C unit cell lengths of the compounds, and these three are the alpha beta angles of the unit cell, and this is the wavelength used by the single crystal XRD data, single crystal X-ray diffraction. So there is no much information about the compound, about the structure of the compound in the zip file, and also you can see here these are the type of the compounds that include the structure, and these are the number of the atoms. So now we can open the HKL file. By using the notepad, we open the HKL file and ins file. So here we can see there are the total 66,000 reflections. Total number of reflections are 66. That are very high number. And we can see first three digits are the HKL values, and this line, this row shows that this column shows the intensity corresponding to this reflection, and this is the angle of diffraction corresponding to this peak or this reflection. How we draw the structure? Let's move on how we draw or how we create the structure. So this is the OLX software interface when we open the OLX software. So for drop the data, we have to open the data by the clicking the file and open. By clicking the file and open, as we open, we can select the data where we have saved. If HKL file or ins file in the same folder, we open only the ins file in the OLX software. If both HKL and ins file are in the same folder, then OLX software also read the HKL files itself by itself. So we open only the ins file. So this is the XRD data, single crystal XRD data given by the professor. Now we open the ins file of the first compound. So I am opening the ins file. We open only the ins file in the olex software. So the ins file has uploaded here for the structure refinement, or to draw the structure we have to go to the work. As we click work, there open the this type of the window, and there is nothing is showing in the screen. So as we click on the solo, the electron density map will be visible on the screen. After solving, you can see that we find the electron density map such like that it is visible in the screen. To solving the structure by this software, we have to the basic idea. We have to learn the basic idea about the structure, that as we open the HCT, so we have to know about the basic idea of the structure about of the HCT. So we can see here the HCT is like that. There is a six-member ring and there is another six-member ring where the different atoms. Here we can label also the atoms, and after labeling the atoms we can see the brown atoms are the carbon atoms. The this one is the chlorine atoms. There is the one chlorine atom. So this one green one is the chlorine atom, and the white one is the hydrogen atoms, and blue ones are the nitrogens, and red are the oxygens, and sulfur is the yellow. So it is the basic idea, basic structure of the compound. So we have to the basic idea, slightly idea of the structure, and after getting the basic idea, we refine the structure. And so we can see here there the six-member ring is visible here. So we can see here there is only one six-member ring and another six-member ring is not there in the ring, in the adjacent of this ring. So we again solve the structure, solve, and we can see that the electron density arranged itself in the another way, and we do this thing until we did not get the required electron density map. So here we can see the electron density map has changed their positions. So again we have solved, we get the new electron density map after solving, and also we can see here there is no ring, there is no electron density in the ring format. So we again solve and solve until we did not get the electron density map in the desired way. So here we can say we get the desired electron density map. So this is the six-member ring, and this is also the another six-member ring which is non-planar. So this is the required or desired ring, desired electron density map from where we can draw the structures, yeah, compound structure. So for now we select these atoms. Now we select these atoms, and this is the carbon. We know that in HCT molecule, there is a carbon member, six-member carbon ring. So we mention it the carbon, and we also know that about the structure of the HCT, that there is the another ring in the adjacent of the six-member ring. So we can also select these atoms by simple clicking on the atom, and we also give the carbon firstly. As we give the carbon and we refine the structure, we can see that what is happening here. And after refining the structure, we will get the R factor here. In this section, we will get the R factor. R factor is the structure refinement factor. So here, it is like a hit and trial method. As we move close to the actual structure, this R factor decreases. R factor is the structure factor observed minus structure factor calculated upon structure factor observed. As we draw the structure closely to the actual structure, this R factor decreases. You can see that R factor is 48%. Since we know that the basic structure of the HCT looks like that, so here we can see that in the other non-planar ring, there is one sulfur atom, one nitrogen atom, and other one is nitrogen atom, and one is the carbon atom. So from here, we can change the atom's name from carbon to the other atoms. So we can see here the bond length. This bond length is about 1.62, and this bond length is about 1.63. So that means one bond is one is the sulfur atom and one is the nitrogen atom, and out of these one is the carbon atom and one is the nitrogen atom. So as we put it as a nitrogen, and it leaves as a carbon, and we change this carbon, this atom as a sulfur atom, and refine again. The R factor change its value. It's taking time, and we can see that R factor does not change. That means the operation that we have done is not relevant to the structure. So R factor does not change. So out of this or this, there may be maybe it since this is the also the nitrogen atom, so we have to change these atoms also. So now we are changing the atom. First of all, the atom is inside the this hole that is shown in the figure. So for select the atom, we have to delete these bonds simply by click on the bond and press the delete button. So this is the smallest electron density that is showing here. So I have to select this, and I have selected this, and now I am changing this from carbon to as a nitrogen. And as I change its nitrogen and refine again. So as I refine, then there will be some change. And as I refine, the R factor decreases. R factor value decreases to 49. So now we can see there is also the chlorine atom, and this is the other sulfur atom. So here we can see in our structure, we can see this bond length is about 1.59, and this bond length is about 1.1.744. So we can say that the atoms that we have marked, this is sulfur and this nitrogen, is maybe incorrect. So we have to change these both atoms. So we changing it to the nitrogen, and I am changing this as a sulfur. So for changing this atom, I have to choose the atom that is present between these bonds. So I have to delete these bonds first and then select the atom. So I am select this, I select this atom and change it to sulfur and refine again. So you can see the structure changes and R factor decreases to 49. So by doing this, choosing the atoms and refine again and again, we will get the final structure. We have to apply this operation, this type of the operations many times, and final we get the desired structures. This is a very time consuming method or very time consuming process. So I have already solved the structure by using this software. As I mentioned you earlier, as I showed you earlier, so you can see I have solved this structure after refining and arranging the electron density according to this structure. So now here, from here, we can, what we can get from this structure. So from here we can get the report. As we click on the report, a report file will be opened in the Chrome browser. So you can see here, this is the HCT report that I have opened by clicking just only at the report. So HCT, this is the table first, and this is the table 2, and this is the table 3, and there are many tables. There are many tables and many information about this compound or about this structure. So you can see in the first table, this is the empirical formula, this is the formula weight, this is the temperature that at which we have done this. We take this single CXRD, and these are the latest parameters, alpha, beta, gamma, ABC values, and this is all the information about this compound that we have solved from the structure. So as we go to the desired structure, this R factor value decreases, and for the correct structure, we can say that the R factor value should be less than the 5%. Now, what the other information we get after solving this electron density map, we got the desired structure that is there, and now we will see that how we can get the other structures, sorry, other information by solving after solving this structure. So I have solved the structure, the SCXRD data of the HCT molecule, and this is the structure of the compound or the molecule. Now, how we get the other information from this? Now we will go to the data where we have saved these files. So as I go to the data, SCXRD data, after solving the data or the structure, you will see that you will get the another files along with the initial files. As you have seen here in the data 1, there are only two files, means that are given by the professor. And as we solve the structure, we can see here that the number of the files increases, means after solving the structure by the OLX, the other files also generated. So what is these files? So this is the zip files, this is the OXM files, means these are the other different type of the files of corresponding to that structure. So now here what we have to do, we open the zip file in the Vesta software and draw the unit cell. How we draw the unit cell? We open the zip file of the compound in the Vesta software. So are opening the Vesta software where we will draw the unit cell of the compound. I open the Vesta software. This is the interface of the Vesta software. So for opening the structure, will go to the file and go to the open. And after going to the open, we will go to the data where we have saved. So in the Vesta software, we open the zip file of corresponding compound or corresponding structure. So I am opening the RML drug zip file. So by double clicking, I have select the file, and we can say here that this is the unit cell of the RAML drug or RAML compound. So this is the corresponding unit cell corresponding to the RAML single crystal XRD data that we have solved in the OLX software. After solving this, we can also take the PXRD data from this structure or corresponding to this unit cell. So for this, for getting the PXRD data, we have to go the utilities. We click on the utilities and go to the powder XRD data. So here we can see there is the powder diffraction pattern. So as we click on this, we get the conditions. Here we can get the conditions. This is the wavelength that is used by the X-rays diffraction, and these are the data range. And there is no other important file. And we go to the reflections. So these are the reflections. And as we click on the calculate, as we go to the plot and calculate, so we can see here we get a PXRD plot or PXRD graph. By clicking this, we can see the peaks of the corresponding to this RAML structure. So this I have opened the RAML zip file. You can see here. So from here we can also get the PXRD data. So this is the PXRD graph for the RAML compound and export graph. As we go to the export graph, it will open the, so the RAML graph is earlier is there. So I am not saving this graph again because it is the same as I have done earlier. So by saving the from here we can save this graph, and that this is all about we have done in our assignment of assignment 2 solid state CML 662. These are the compounds that I have solved. This is the first compound, hydrochlorothiazide, that we have solved, and this is the unit cell corresponding to this molecule, and this is the PXRD pattern corresponding to this compound, and this is the another compound RML, and this is the structure of this compound we can see here, and this is the unit cell that I have shown you in the Vesta corresponding to this compound, and this is the PXRD pattern that I have shown, and this is the third compound. This is the ROPA drug. This is the structure of this compound, and this is the unit cell of this compound, and this is the PXRD graph or PXRD pattern of this graph. So it is all about the all about this assignment. So thank you.